Hello again. This is probably going to be in another week, so good week if this is a new week for you. We are still with the revision exercise, and we're preparing for the test that's going to happen on the 25th or the 26th of this month. We've done a couple of exercises, revision exercise. We've done A, B, and C. Okay, I've shown you A and B. Hopefully C you'll figure it out, or at least by looking at the memo. I'm going to do D for you today as an example. Okay, C, E, I'm going to chat a little bit about that, but I think you'll be able to do it. It's not too difficult. I'll chat a little bit about if. Okay, again, I want you to do it on your own, and then I'll probably show you how to do G. Okay, and then H, again, I'll send you to do on your own. So we are in D. Okay, and we've got this circle. This is the middle of the circle. We're told that A, B, C, D. Yeah, please check me, guys. D in page 171, actually, not in 72, 71. We're told that this shape is a kite, okay? And we asked to prove that AOB, triangle AOB, is congruent to AOD. Okay, identical, congruent, identical. Okay, so remember we need to do this whole S, all these kind of things. Now we already can see that there's one angle that is the same. Okay, A1 is equal to A2. So let's write that down. A1 equal to A2. Give it. Now we also have one side which is very obviously the same. Okay, so check this. AO is obviously equal to AO. It's a common side. Okay? Why is that important? Because that side, that AO, belongs to the triangle on the left and the triangle on the right. Okay, so we already have a side and an angle. Now if we either get another angle, which is possible, a bit more difficult, or we can just get another side, which is the other side of an angle. Okay, now let's have a look at AB and AD. I know that AB equal to AD. Why is that? Because these are adjacent side and a kite. And the kite, the adjacent sides are equal. That is equal to that, and that is equal to that. So these are adjacent sides of the kite, which are equal. Okay? See, this is why geometry is so difficult. There's so many things to remember. You need to remember that in a kite, okay, the adjacent sides are equal. Okay? So now I've got a side, an angle, and a side. The angle is sandwiched between the two sides, so I can say AOD, triangle AOD is congruent to triangle. It's very important to write in the right order. AOD is congruent to AOB. Okay? And give the reason we need to quote. What did we find? Side, angle, side. So I need to write SAS. Okay? So that's the first part, and that was actually the hardest bit. Next thing, prove that BOC, triangle BOC, is equilateral. Equilateral means all sides are the same. All the sides are the same. Now, how would I do that? Okay, I can already know that these two sides are the same. How would I know that these two sides are the same? Because they are radii, they're radiuses, they're both radiuses, okay? Because always the central circle, okay, is the central point. So any line that goes from that central circle to the circle is a radius, and they're all equal. So I can say BO equal OC, okay? They're both radiuses, radii, okay? All the radii are equal. Now, I just need to show that BC is the same as well. Now, how could I do that? There's a couple of ways of doing this. Okay? I might be going the long way around. Is there an easier way of doing it? Look, I'll go through this one way. If I know that this is 30, okay, I know that B2 is also 30, because these sides are also equal. Okay? Because these are radii. So let's go like this. We'll start with BO equal OA. Again, they are radii. They are radiuses. This is a radius, this is a radius, this is a radius. And that means that B2, okay, that was 2, I think. B2 is also equal to 30. Okay, these angles are equal because equal angles opposite equal sides. Okay? So this is a 30. Now I can figure out what is this angle. Okay, we'll call it O3. O3 plus 30 must be equal to 180. I'm looking at this triangle. Okay, 30 plus O3 is 180. Sum of angles in triangle. Okay, so O3 is equal to 120. So this is 120. Now, that means if I know O1, let's do it like that. Yeah. There probably is an easier way of doing it, but never mind. Okay. So if O3 is 120, how many are we in? Okay, so I can say that, let's do it this way. O1 plus 120 equal 180, because these are adjacent angles on a line. Okay. Right, this is, I don't know what it is, but if this is 120, together they add up to 180. So O1 is 60. But now I know that B1 equal to C1. Why do I know that these two are equal? Because they are opposite equal sides. Okay? B1, did I write it somewhere? No, I didn't write it. But I know I wrote that these two sides are the same, so the angles are the same. So equal angles opposite equal sides. Okay. So if these are equal, then I can say, let's call them, let's say that we call them x. We'll just call them x. So now I can write an equation for the angles in this triangle. I'm going to write x plus x, because each one of them is x. Okay? Plus 60. Okay? Plus 60. That has to be equal 180. I don't have enough space here, but you know the reason. Sum of angles in a triangle. So 2x equal 120. X equals 60. Okay? And if I have a triangle, okay, where all the angles are 60, right? O1 was 60, this is 60, and this is 60. Therefore, I can write down, therefore, triangle OBC is equilateral. Okay? If I've got a triangle with all the angles are 60, that means all the angles are the same, all the sides are the same. It's equilateral and equiangular. Equiangular means have the same angles. Equilateral means the same side. But if they all have the same angles, therefore all the sides are the same. Okay, I'm just going to pause here. Okay, I've decided question 3, I want to prove that DOC is equilateral. I'm not going to write it, but I'm going to take you through it. There's two ways as far as I can see. One way, you just as you show that all the angles are here 60, you can do the same thing here. Show all the angles are 60 in the same way. But there's a quicker way. And what you could say is, look at these two triangles, DOC and OBC. We're going to try and prove, we can prove that they are congruent. And how are you going to do it? We're going to use side, angle, side. Now, those two sides, OD and OB are the same because they're both radiuses. OC is a common side, so obviously it's going to be equal. So I've got two sides. And then we're going to prove that these two angles are the same. And how am I going to prove that? Well, I can say, just like I proved this is 60, because this is 120, I can prove again that this is 120, because it's exactly the same reason. This is 30, this is 30, they're equal to each other. Therefore, this is 120, therefore this is 60. So now I've proved that side, angle, side. Now, if these two triangles are congruent and all the sides are the same here, therefore all the sides are the same here. So it's a little bit difficult, but I'm taking you through it, okay? Next thing, I want to show that BCDO. I want to show that this triangle, or quadrilateral, is, what do you call it? Parallelogram. Now, how you do that? I will do it like that. If I just showed that, what did I just show? I just showed that these two triangles are both equilateral. That means they're all 60 degrees. All the angles are 60 degrees. Okay? Now check out these two angles, this and that. This is 60, this is 60. Okay? These are alternating angles, aren't they? and I'm shown that they are equal to each other. So I just got to write down C2 is equal to, what angle is this? I can't see, O1. C2 equal to O1, okay, because I proved it. And then I say, therefore the line CD is parallel to BO. Why are they parallel to each other? Because alternating angles are equal. I showed the alternating angle are equal. So I just proved that these two lines are parallel. But to prove that it's a parallelogram, I need to also show that these two lines are parallel. Okay? How would I do that? Well, the same way that I know that this is 60 and this is 60, these are also alternating angles. So once I saw this is 60 and that's equal to 60 as well, both of these angles are equal, then I can say these two lines, BC is parallel to OD because of a pair of alternating angles that are equal. So it's a parallelogram. Next thing, they want me to prove that the same shape is not just a parallelogram, but it's actually a rhombus. Okay? Now, if I proved already these triangles are equilateral, that means that's equal to that, which is equal to that. That means that is equal to that to equal that. That means all the sides really are equal. Because if that is equal to that, and that is equal to that, and that, all these sides are equal. So OD equal DC equal BC equal OB. They're all equal. Okay? And if a parallelogram, all the sides of parallelogram are equal, we call it a rhombus. So once I prove that all the sides in this parallelogram are equal, I can say it's a rhombus. A rhombus is a parallelogram where all the sides are equal. A lot of stuff to remember, I know. Okay, next thing I want to prove, this is 6. BOD equal to BAD. BOD. Okay, in fact, I've kind of done, I've done it. So if I know this is 60, BOD is 60 plus 60. So BOD is 120. Okay? BOD is 60 plus 60 is 120. BAD, I know this is 30 and this is 30, so BAD is 60, so obviously 120 is double 60. So that was quite easy. And then last one, I want to show that AB, okay, that sign means perpendicular, 90 degrees. So line AB is 90 degrees to BC. So I want to show that this is 90 degrees. But I've already done it because I know this is 60 degrees and I know this is 30 degrees. So 60 plus 30 is 90. So the last few were quite easy. I know, guys, not an easy question. Please do that. I'm going to just take you through to question E. Okay, just pause it here for a second. Okay, so this is question E. I'm not going to actually solve it for you. I'm just going to quickly take you through it. It's pretty easy. They want me to show that these two triangles are similar. Similar, they're not congruent, not identical, they're similar. And because I don't know anything, to prove that triangles are similar, either they have the same angles, equiangular, so angle A equal to D, C equal F, and so on, or that their sides are in proportion. And this, we have information about the sides, so we're going to use that bit. Okay, you can see that 10 is double 5, 8 is double 4, 14 is double 7. So what am I going to write down? How do I prove that? I'll say FE divided by BC is 10 divided by 5, which is equal to 2. And I got to do it for all pairs of sides. So DE divided by AB is also 2. I need to do it. And then once I show they're all equal to 2, then I can say, great, okay, the triangles are similar. In 2, once I prove that the triangles are similar, then obviously they're equiangular, because if they're similar, they'll have the same angles. Okay, so that's about that. I think I'm going to do, if I'm going to leave you to do on your own, we've done similar question like that. Let's do G. Let's start G. I don't know if I will finish it, but let's start G. Okay, so we're going to start with, this is question G in page 172. Okay, if you should manage. G again, I want you, before you listen to this, have a go, pause me now, have a go at it, spend 5 minutes or so, see how far you can get, okay, and then you can listen to this video if you didn't get it. We are told, okay, this is 90 degrees, this is 90 degrees, these sides are the same, this is 1 centimeter, this is 4, okay, so immediately I can say this is also 4, okay, let's write it, okay, and that's it. And they want me to prove that triangle AEB is congruent to DEB. Is that right? Yes. Okay. So how do I do it? Okay, I need to think side, 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 triangle, side. Okay, I already know one side which are equal. These two sides are equal. I know this side, okay, is a common side, so it will be equal. And then I've got an angle. This is 90. Okay, so the first thing I would do, okay, if I were you, okay, this is 1, this is 2, I would say E1 plus E plus 90, this is, I know is 90, equal 180, sum of angles in a triangle. So E1 is also 90. So the first thing I'm going to say is E1 equal E2, which is equal to 90. Just proved it, okay? Next thing I would say, EB equal to itself. That's a common side. Okay, so I've got one side is the same. Now I've got AE equal ED, which is given. Okay, so look at this. If I highlight these three things, I've got a 90 degree, they're both 90 degrees triangle. Hang on. Okay, no, I didn't even need to go that way. Okay, so I've got two sides that are equal. This is equal to itself, this is equal to itself, and an angle in between. Okay, so therefore I can say triangle AEB, triangle AEB is going to be congruent to triangle DEB. Okay, and the reason is SAS. Okay, so that's the first part. Okay, 2. Prove the ABC and ABC. Let me just pause you here. Right, so now they want us to prove that triangle ABC, the big triangle, is similar. This means similar to AEB. Now, I really recommend you to just have a look. That's why I've written what they want us to prove. Okay? To prove similarity, either prove that there's a proportional ratio between the sides or that the angles are the same. Now, check out here. Okay, these two angles have to be the same. Angle A has to be equal to angle A. But obviously, it's the same angle. So you're going to write angle A equal to angle A. That's obvious. Okay, given A, or common angle. So just like a common sine, you have a common angle. Now let's have a look at B and A. B, okay, angle B in the big triangle is 90. Angle E is also 90 in AEB. Okay, also this we just proved is 90. So I can say that angle B is equal to angle E1. I just need to be specified because we're talking about A1 because it's triangle ABE. It's also equal 90. That we proved that. Proved that it was given. We proved that E1 is 90 and B is given. So proved and given. All right. Okay? Therefore, if I've got two angles, two pairs of angles are the same, therefore the last angle, okay, C must be equal to B3, okay? Angle C in the big triangle must be equal to angle B3 in the small triangle. Have to be sum of angles in triangle, right? If I prove, we spoke about it in one of the last lessons, if I prove that two angles are the same, then the third must also be the same, okay? Now I want to calculate the value. Okay, let me just make some space. Okay, so here now they want me to find out x. If I know this is 4, obviously that means that's 4 as well. Okay, so the same, and this is 1. So I want to find x. Guys, not easy. Okay, now we're using the proportion, or not the proportion, the fact that these triangles are similar to find x. And how are we going to know it? Okay, this side, AB, in the small triangle, where's the small triangle? AEB. The small triangle, AE, over DE, where is DE? Okay? No, I don't have DE. AB. Looking at the arm, because I'm looking at the wrong triangle. Okay? So AB over AC, AB over AC, okay? The ratio of these two triangles will be the same as, which one are we going to choose here? I can choose, for example, AE and AB. No, I've done AB. Okay, I could do that. I'll just pause it for a second. Okay, so I think I can't remember where I kind of paused, but let me have a look at it again. So we're trying to find x, and we know we're going to work here with ratio of sides. I know these two triangles are similar. So I said AB, the side of the small triangle, divided by AC is going to be, for example, equal to, which one I'm sure I thought I will do, it will be equal to AE divided by AB. Okay, so I'm going to write equal to AE over AB. Okay? And the reason is, what was, I can't remember, proportion, corresponding angle proportion. What was the word we used for this? I have to look at the examples again. Corresponding side in proportion. Corresponding sides in proportion. Okay. So what is AB? AB is x. AC is 4 plus 4 plus 1 is 9. AE is 4 and AB is x. Okay, so how do we do that? We're gonna, what you can do is find the common denominator, lowest common denominator, which is 9x. So it will be 8 divided by 9. So it's going to be 9x, right? So 9x on either side. Okay. So I have to multiply that by x. So I have to multiply x by x. It's x squared. I have to multiply x by 9. So I have to multiply 4 by 9. It's 36. And then we cancel the 9x. We multiply it by 9x, remembering that x is not allowed to be 0, but it's fine, because x can't be 0 here anyway, it's a side. So x squared equals 36, and that means x equals 6. So we found x. Okay, let me pause and have a look at the next question. Okay, last two questions. I'm not saying they're easy, but I'll just try and take you through it without actually writing. It's because I'm getting a little bit tired. So they ask you to find out what is BD. Okay, we just found that x equals 6. Now to find BD, what you need to notice that these two triangles, ABE and BDE, are congruent. How would I know that they're congruent? Okay, I've got two sides that are equal. Okay, 4 equals 4. I've got two sides that are equal, the common side. And I know that these two angles are equal. Actually, hang on, I'm being ridiculous here. Didn't I already prove it? AEB. Yeah, already in the first question, I proved that these two triangles are congruent. Obviously, I proved that these two triangles are congruent. So if they're congruent, that means that the corresponding side must be equal. So this equal to that. So all I got to say is BD equal AE equals 6. Because these are corresponding angles on congruent triangles, okay? So that's the first bit. Then they're asking me to find BC. Now, how would I do that? I want to find BC. I know this is 6. I know all of this is 9. Now, this is 90 degrees, so I'm using Pythagoras, okay? If this is 6, okay, this is hypotenuse is 9, you should be able to use Pythagoras to find the missing side. Okay, guys, that was a long lesson. I'll give you obviously a double lesson for this. I want you also to have a go at H, and I'm not going to go over it here, but check the memo, please. And if you don't get it, please ask me, and I can put another little video on YouTube, on the WhatsApp maybe. That's it, guys. Cheerio.